Good morning. Today we're going to talk about types of fossils and continental drift. So types of fossils. A fossil is a trace or remain of an organism that lived long ago. Most likely you already know that. They can be found in a multitude of ways. They can be trapped in amber, such as seen in this picture right here. Often this is remembered as a scene from Jurassic Park with the yellowish orange material. Basically what happens, the insect gets caught in hardened tree sap and then over time it crystallizes. They can be trapped in asphalt, such as a tar pit. This picture represents the La Brea tar pits found in California. This generally gives us information about what insects were like in the past. Specifically for the Brea pits, this would be what California insects were like. They can also be found in buried rock. So dead organisms basically are quickly buried by sediment on top of it, so dirt and other materials that basically cover it up. And that preserves the bones, and they basically become part of the rock itself. That's why we can then basically take them and brush them away over time. Somebody like an archaeologist or a paleontologist, somebody who studies like dinosaurs or bones or old artifacts, they can find these materials and then they start using certain tools to basically remove all of the rock and organisms around the actual fossil itself. They can become petrified, often remembered as seen as petrified wood. Basically, the organism's tissues decay away and they get replaced by some kind of hardened mineral that turns petrified over time. They can also become frozen, such as the mammoth and ice picture. And basically what happens when a plant or an animal freezes, it will die. And then those cold temperatures help preserve the skin and the bones on that particular animal or plant, thus leaving it partially intact but frozen. Then you have a trace fossil. A trace fossil gives you an idea about what an animal's behavior patterns might have been. It also gives you an idea of the fact that they were there, but it doesn't actually give you a true fossil. So it's a fossilized structure that forms in sedimentary rock by the activity of the imprint or the indentation that the animal was there. Footprints such as this, burrows such as an animal burrowing into a hole in the ground, or coprolite, which is animal poop. All of those are trace fossils and they crystallize and harden over time. Most commonly, footprints will be found. So what do fossils tell us? Well, they show us about the history of life and environmental changes that have occurred over time. Example, a fish fossil would represent an aquatic environment. A palm frond would represent a tropical environment, like a palm tree. And then, of course, we also know that tree and animal dinosaur fossils have been found in Antarctica, which basically tells us that at one point Antarctica had a warm climate, that it was warm. It also shows how life forms have changed over time. All right, Pangea. In the late 1800s, a man by the name of Alfred Wegener, who was a German scientist, basically claimed that the continents were once joined in a single landmass called Pangea. Pangea broke apart and the continents, quote, drifted to where they are today. This is the theory of continental drift. Three main evidences for Pangea. Evidences for Pangea are, number one, mountains. So they believe that the Appalachian mountain range lined up with Africa, which, as you note, this like sideways shape of the continent, pushed together with what would be the Appalachian Range here in America today. The second one is the Mesosaurus fossil. The Mesosaurus was a reptile that was found in both South America and in Africa. As you can see, here's the Mesosaurus, and he was found in southern South America and southern Africa. Clearly, he was able to go from point A to point B. There is another fossil, the Cenotasaurus. Sorry, I can't really say it. But it was also found on South America and in Africa as well. And the Lystrosaurus was found on Africa, India, and Antarctica. And we currently know that Antarctica is frozen, but this helps provide proof that at one point it was probably not. And lastly, note that not all three of these animals are water animals. It does look as though the Mesosaurus may be, but the other two are not, and they would have traveled from one continent to another. If they can't swim, they couldn't have done that without walking. The third and final evidence is the Glossopteris fossil, and it is a tropical fern, and it's been found on all parts of the continents, including Antarctica, indicating the warmer climate it once had. Now, Wegener was not accepted because he could not explain the why. Why were the continents moving? So at the time, when 1800s, Wegener was not accepted. This, again, is another picture to show where each of the different things were located. Clearly, it supports that there was land reptiles moving from one continent to another. All right, this is the idea of Pangea and what they believe it looked like. So about 245 million years ago, the continents were in a single landmass. And then about 200 million years ago here, they split apart into a northern part, into a southern part. Laurasia, hence the term Asia, is in the north, and then Gondwana was in the south. Then about 150 million years ago, a rift started forming between South America and Africa, causing them to split apart. And then India, Australia, and Antarctica kind of started separating and becoming independent pieces. And then 50 million years ago, India and the other continents started moving to present locations. And India started pushing forward into the continent of Asia, creating the Himalayan mountain range. It is currently still pushing forward today, and the Himalayas are currently growing. All right, so there was some support for continental drift in Alfred Wegener's theory later in his life, or later past his life. So the mapping of the ocean floor led to the discovery of the mid-ocean ridge that we talked about with oceans. This was able to answer the question as to why the continents themselves were moving. So there are three things about it that were important. They found the age and magnetic properties that would be found on the ocean crust here, that the youngest was closest to the ridge. So anything that was young was close here to the magma. As the further away you would go, the older the rock would become. The second thing is seafloor spreading, which is where crust is created. As this molten material, the magma rises up through the Rift Valley here. In the mid-ocean ridge, it would push out of the old rock and cool to form new crust, thus supporting the youngest crust being near the middle. This also showed the continents traveled with the ocean floor as it separated and went further away. The last thing is an ocean trench, which you can see here, where one trench piece is going underneath another continental piece, and the dense floor actually sinks back into the mantle, thus melting.